Am I audible clearly? Right?
Yeah, man, you are right.
Yeah.
Okay. Okay. So today discussion we will like cover or we will discuss about your polycarbonate as well as the copolymer of styrene because we have already know how the styrene has been manufactured and what is the basic property of styrene. But we have to know the basic or the importance of the few copolymer of styrene that have a very huge demand in the market due to its quite versatile properties. That is the reason. Okay. So for that, this polycarbonate is a very hugely demand polymer that we are using. Okay. So the polycarbonate, if you see this kind of linkage, actually this linkage is only known as your polycarbonate. That is known as your inter-unit linkage. Suppose if you see this whole portion will be calculated as your polycarbonate. So how this is prepared? For the preparation of polycarbonate, you require the two monomer, okay? And the two monomer, one is your bisphenol A, another one is your phosphazine, that is your you will use this polybisphenol A or like right now there might be chances like you can use some other monomer also. But in the market, whatever the polycarbonate that is coming to the in the market, they are basically using like bisphenol A, phosphine gas, okay, and in your methylene chloride and water mixture. Okay, so they use this in the presence of H2O plus NaOH. They will form the mixture with the help of this reaction. So this will be basically do this water molecule. Okay, here from your H2O will be removed. Okay, and you will get this finally polycarbonate. And this is one type of your condensation polymerization also. Uh, in this polycarbonate, if this kind of granules that is available in market and polycarbonate available in basically in the form of granules. And if you term into some chemical terminology, so this polycarbonate may also made by the ester interchange between your polyester A and diphenyl carbonate. So these are the two methods by which your polycarbonate is manufactured. First is your polycondensation reaction that will occur between your bisphenol A and with the uh, phosphine. Next, we can do a ester interchange reaction. Okay, this is the ester interchange reaction that will be occur between your bisphenol A and diphenyl carbonate. So in the both the cases, we can form this polycarbonate. So this property, the polycarbonate have a very wide range of application due to its quite uh, property that have and that attract the market with its property. What are this property? First of all, it is a thermoplastic polymer. Okay, and as well as it is amorphous because if you see that polycarbonates are quite transparent due to a contain of highest amount of amorphous percentage. Uh, That is means we know that if we have like 60 to 70% of amorphous, then the 40% will be your crystallinity. Yeah, and this polycarbonate, as they are manufactured from the polycondensation mechanism, they follow this. So, due to this heavy structure, they try to form a very randomly oriented polymer chain. The chain or the this linkage will be in a quite random form. Okay, they will not just form this straight kind of chain. If I want to just so here you can't see this kind of straight chain. Here you might be have this kind of like the helical path or this kind of structure. That is the reason they contain more percentage of your like amorphous in nature. There it will be contain more amorphous. And due to this more amorphous in character, you can see they are quite transparent in nature. Its chemical structure give a very unique blend, okay, or the unique combination of your physical as well as your optical characteristic, which are useful for many applications. Due to this chemical structure, okay, it has, see, if you look into this benzene and there is a benzene ring, okay, so here you got somehow your strength will be quite good on this matter, but simultaneously you can see there can be a flexibility also due to the present of this is known as your ester bond, okay, we call this as a ester linkage, okay, this is ester interchange or this is your ester linkage. Due to the presence of ester or ether, this is known as your ether and this is known as your ester. Due to the presence of these two group in this particular polystyrene, polycarbonate, they got a quite combination of your physical and optical characteristic. That is the reason which which helps them for many industrial application. We will know one by one like what are the industrial application also. But polycarbonate is particularly transparent. They are quite transparent. If we compare them with your PET means polyethylene terephthalate, high density polyethylene and polystyrene. If we compare the transparency or the transparency, because if you have a transparent in nature, then what you mean by that? The light can be easily passes through that particular material. So if light is passing through that material means some refractive index is going to be there, right? So if we have a refractive index concept, then automatically we are come across your optical characteristic. So that is the reason here we came to know that this polycarbonate have more transparency as compared to your polyethylene terephthalate, HDP, and polystyrene, and has a transparency that is equivalent to your silicate glass. You saw the glass, okay, the water you drink in the glass made of silicate, okay, or that glass, how they are quite transparent, means we can see also in that. So as this polycarbonate have a comparison, the transparency have a comparison with this silicate glass. And that is the reason, if you see, due to that transparency, this polycarbonate maximum they use in your window glass, na? There, half of them are manufactured of your silicate glass, and half of them is manufactured from your polycarbonate material. But how you will identify? Okay, suppose if you know, okay, like how I will identify, okay, this is the silicate glass or this is the polycarbonate. Okay, so when they settled into the pieces, okay, this glass can be edges can be quite settled or they are quite uneven. Okay, but if you see the polycarbonates, they are little bit flexible in nature as compared to your silicate glass. This polycarbonate is also known for its high impact resistance. And if you consider about your impact resistance, means that is 250 times, means 250 times more the impact resistance of your glass. And I have already I have already discussed in the lecture that what do you mean by the impact resistance or impact resistance. In short, it is that like how a material is resistance to a certain shock if you give to that material. Okay, that I have discussed in the like last lecture also. Suppose if we are plating the stone into that, that is also one kind of energy that the material is absorbing. So if you go into that terms, or how much energy that particular material is required to just break into a pieces. So that is known as your impact resistance. So this polycarbonate is known for its high impact resistance. Okay, and that make this polycarbonate more suitable for many of the automobile industry, where this polycarbonate used as a glass or that where the driver's seat drive, you can see the glass silt over there, okay, or the glass window. So maximum time this polycarbonate used there as the glass window, as because they have a quite high impact resistance, as well as they have a high impact resistance and they are quite transparent in nature. And this impact resistance, if we compare with the normal silicate glass, this polycarbonate impact resistance is 250 times more than the impact resistance of your glass. Okay, this as well as this include a exceptional high impact strength even at low temperature, low moisture absorption, good heat resistance, good rigidity and electrical property, and high light transmission. So if even though the temperature is low, okay, means up to like 5 to 10 degrees Celsius also, you can find that the impact resistance of this polycarbonate is quite okay, or it is quite high. And as well as they are the low moisture absorption, means the moisture we can use them for the outdoor application, as the moisture absorption is quite low in that case. Okay, and good heat resistance, it can resistance, we will see the melting point of this, so that also you can see. So this good heat resistance, it is if we go into the structure of this polycarbonate, it is quite interesting. See, due to this presence of these two benzene ring over here, they can quite resistance to your heat, because when you supply the heat to them, this heat will convert into a energy, and that energy, this benzene ring have that much ability. Okay, this benzene ring have that much ability to like dissipate the heat among themselves, so they can resist to quite high temperature also. That is the reason they are good heat resistance and good rigidity. The rigidity is due to the presence of two benzene ring across this alkyl group. Okay, due to presence of, see, this ester group and sorry, this ester group and this ether group, they are help you for the flexibility, but due to this presence of this two benzene group, here they can be form good rigidity, as well as they are electrical properties. They have a very good electrical property, because there is a concept in the chemistry of the charge density. Okay, so, because if you look into this structure, this this have a double bond over here. Okay, so they have a very good amount of electron cloud in this like benzene and in this benzene. So what will happen when the electric current will come across here? The charge, okay, because you know the current means the flow of the electrons. So that electrons will be flow over here and flow over here, and that is the reason they are quite high. They are having a electrical property as well as high light transmission. Due to this high light transmission only, they are quite transparent, as well as they are transparent more than your PT, SDP, and PS. Okay?
That piece, one doubt, that PC we are using along with ABS also, right? PC, ABS.
Ye- Yes, yes.
Okay, so what will be the percentage of PC we are using with ABS?
I will talk about that. I make the PPT of on the copolymerization. There
Okay,
you will have a like clear out how much percentage, because the
okay.
amount of PC we are increasing, that affect your final property also. So we have like
Basically, we are
uh,
adding PC only, right, in ABS.
yes, yes, yes.
And why we are adding? Because what are the reasons to add PC?
What are the reason we are at PC? You tell me. I have just completed like 2 days before. I told you some limitation of PC. What are they?
No, no, no.
They
Okay,
are,
we are adding PC in ABS, right?
yes, so PC have some limitation, right? As like ABS has also some limitation. So why we do the copolymerization? Because individual polymer have their own limitation. Like PC have limitation toward the heat resistance. Okay. Polystyrene are not like they are having a very less resistance in the environmental stress. So adding this ABS help them to get more flexibility in the outdoor application. And
But
that we
we
will study. Yeah.
but we are adding PC in ABS. So ABS having some limitation. That's why we are adding PC, right?
Yes, and PC also having some limitation. That's why vice versa. Okay. If you are adding PC in ABS means what? You can add ABS in PC also. But if you change the percentage of PC or ABS, which property will be higher? According to that only you will change the ratio of the both the polymers.
Okay, that's what. What is the main reason to add a PC in ABS. And what is the main reason for transparency or
Can we discuss that after 5 to 6
okay,
flight?
okay, that's
Yeah,
also okay. Good.
yeah. Let me complete this. Yeah,
Yeah, please.
yes. Um, Okay, so these are the few of the property of your polycarbonate. And this polycarbonate, however, has a limited scratch and chemical resistance. As I told you, they are high impact resistance. Okay, so due to this high impact resistance, they have a very limited scratch. Okay, has a limited scratch, and they are quite good in the chemical resistance. What do you mean by the chemical resistance is that I will talk over in this by taking this example. See, they are quite chemical resistance. Means if you pour this concentrated acid, okay, if you pour this concentrated acid in the polycarbonate material, okay, so this polycarbonate material is not going to be affected, okay, as they are resistant to this concentrated acid. But this polycarbonate will be dissolved. It will be dissolved if they are diluted acid or alcohol or aliphatic hydrocarbons or aromatic hydrocarbons. If these are the material, then they can be quite compactability means this polycarbonate is dissolved if we have a aliphatic hydrocarbons, grease or oil, okay, means they have a quite good compactability with this, okay, but they are very affected by this few of the acids and alcohol. Next, polycarbonate is has a ability to undergo extreme plastic deformation while not cracking or breaking. See, this is very important point. This plastic deformation means your polymer is about to change or it get okay, I'll show you in the graph. There is a two term that is known as elastic deformation and plastic deformation, and this two terminology is the same concept with your metal also. So what do you mean by this plastic deformation is that if you see this is your stress. Stress is the amount of forces you are applying. Okay, this is your stress and this is your strain. This is your strain. Strain means how much I can stress this material. Okay, so if we see this kind of graph, okay, then from here we will see this kind of graph. Then this. So this linear curve, okay, this is the linear curve. This is known as your elastic limit. What do you mean by elastic limit? If I apply the force and try to stretch that polymer into some extent, okay, if I stretch this polymer into some extent, but when I release it, means when I release the force, then again the material will come into its original position as like the rubber band. Okay, if you stress, but when you release, they come back to its original position. So that is known as your elastic limit or the elastic deformation. What do you mean by the deformation? Deformation means change in the structure or the change in the phases. So and what do you mean by the plastic deformation? This is we call this as a yield strain. Okay, that you will study in your mechanical property of the polymer. What do you mean by stress, strain, strength, and the yield strain? So after this yield strain, okay, you find that materials start your plastic deformation. Okay, what do you mean by plastic deformation? Means when you apply the force, it will be straight. But when you release the force, the material will not again come back to its original position. There is a permanent deformation. Permanent deformation means the material is suppose extended to some distance. When you release them the force, this material will not come back to its original position. It will be stay in this manner. Okay. And this is a very important property of that polymer. If that if this plastic deformation is occur, okay, that means after that your polymer is about to be fractured. Okay, fracture means it will be break into two pieces. Understand? This point is known as your fracture point. Means your polymer will be break into two pieces. Okay. So that is what it is written over here is that polycarbonate it have a ability to undergo extreme plastic deformation while not cracking or breaking. Means directly it will be break into two pieces. Okay, you can't see like some polymer, if you see that, okay, half of the portion is about to break, or you can see some cracks is initiated, okay, before they are going to this plastic deformation. Means before you are trying to, like, before their fracture point is to come, this polymer is you can see some what can I say? They will show you some kind of uh, instinct like this polymer is about to break. But this polycarbonate, they will directly broken into two pieces. You can't see any kind of cracking before the breaking or anything. Okay. So, when during this plastic deformation means from changing or to break, going into the other phase, they will not show any kind of cracking or breaking. Directly, the material will be fractured.
Basically, PC having very big plastic reason, plasticity reason, right?
Yes,
It is not
they
like a
are.
brittle that it will broke suddenly, kind of.
Yes, yes, yes. It will be not break very see if you see any you search in the Google also. This polycarbonate have a very huge amount of your reason for the
Plastic
plastic
reason,
deform.
yeah.
Yeah.
Right.
So because what happen if your polymer, see, it is a very advantageous, huh? Those polymer have highest amount of plastic range. Okay, there they can be have a very strong strain. Okay, or the load dissipation means if you apply like 2 Newton, 3 Newton, so the force is actually distributing without going to the final fracture. So that is a quite advantages of your polycarbonate material. So have you seen
But
that like
shape will change, right?
yeah, shape will change. Shape will change, definitely.
Mm,
Shape will change, but you can't see like crackings or breaking. Like
right,
you
right.
can't see that. if you see any polymer, like if you try to bend them, you see some crack will be initiated
Okay.
suddenly. Okay, that you are unable to see in the polycarbonate. See, generally in the market, if you see this polycarbonate have a always comparison with the polymethamethaacrylate, because this polymethamethaacrylate have the same kind of property and same kind of features as like your polycarbonate. But your polycarbonate is giving you more advantages because they have very limited scratch and they have a very high impact strength as compared to your polymethamethaacrylate. We have a comparison table, and this polymethaacrylate that will be taught you by the Pavan sir. So he will give you a very proper explanation to that. But for in the market, there is a huge comparison always between your PMMA and PC. That is the reason I'll also highlight you few things about that. Okay?
Yeah, you're right, because some lighting application somewhere they are using PC, somewhere PMMA. Yeah, you're right.
PMMA, yeah, yeah. Uh, even
But
PMMA
uh,
have a
but uh,
very
but how to distinguish where we have to use PMMA any, or where you have to use
that
PC?
is that is depend upon your scratch resistance. Actually, I have also no knowledge, but uh, according to few of my friends, these are working in the automobile industry. They are saying that as PC have a scratch proof, so they will maximum go for the PC.
PC have less.
Otherwise,
PC have high scratch
eh,
resistance, right?
yeah, high scratch resistance.
Compared to PMMA. Okay,
Yes, yeah.
that
So,
is the reason.
yeah, according to your application point of view, but PC is little bit costly than PMMA. Yeah,
Okay, basically it's a balancing kind of. Yeah, got your point. Yeah.
yeah. This polycarbonate plastic provide very excellent heat resistance, as I told you. Excellent heat resistance due to the presence of two benzene group. They are excellent heat resistant, which facilitate good hygienic condition while cleaning at high temperature. Okay, means suppose if you provide some temperature as they are quite heat resistance, so they are less hygienic, means we can use them for your biomedical field and we can use them in your uh, for the sterilization purpose also. So the density of your PC is generally is in the range of 1.2 to 1.22 uh, gram per centimeter cube. So this density and the tensile strength will be 55 to 75 megapascal. If you see this Young's modulus is nothing but your stress by strain. That is, this is will decide the Young's modulus. Young's modulus
This
is
is stiffness called EE value, right? Young's modulus.
yeah. That is
Okay.
your stiffness of the material.
Right,
Yeah,
right.
and that is your elastic reason only. Your Young's modulus will give you the value of your stiffness, and that is you can calculate it by this elastic reason. And the compressive strength is greater than your 80 megapascal, and the melting point is how much? 267 degrees Celsius. That is the reason they consider as a excellent heat resistant. And this polycarbonate material, they can be used for your sterilization purpose. Okay, sterilization means you can use them for your biomedical field where you deal with the microbes, organism growth or the enzymes. So if you, I don't know whether you know or not, but if you see in the bio field, there we got a Petri dish. Petri dish means it is just looking like this. You have a like this circle, and there we can grow the cultures, or we can grow some bacteria to like for healthy reasons. Okay, so that we use this known as petri dish. So that petri dish also manufactured from your polycarbonate material, as because we need to sterilize them around your 105 to 120 degrees Celsius. Okay, so that no external microorganism can attack over there. Only the microbes I want to grow, that only I can grow. So the sterilization process in the bio or the medical field is a very quite important. So that is the reasons this polycarbonate they use, and they have a quite excellent heat resistance. Due to that, they have a melting temperature around 260, it is a range, okay, 265 to 267 degrees Celsius. And the glass transition temperature is how much? 150. Okay. So, due to the presence of high glass transition value, okay, they are like sustained, or they can have a like high impact strain even at the low temperature. So the strain can be like sustained at the low temperature also. So, but if there is some advantages, so might be there is some disadvantages also. So what can be the limitation of polycarbonate? It also has a tendency, this PC, okay, this polycarbonate, again, as I told you, these two benzene ring, due to this two benzene ring, one is this, another one is this. Due to this two benzene ring, we got lot of advantages, like they are heat resistant, they are sustained in the very worst weather condition. They have more plastic reason. They have high impact strength due to these two benzene ring. But this benzene ring have the double bond. So when they have a contact with your UV rays, okay, or if they have a contact with some sunlight, or that is contain the UV rays, okay, so there might be chances your polycarbonate can be degraded, and that degraded you can have if they turn into the yellow color, as they long-term exposure to UV light. If you expose this polycarbonate, okay, if you expose this polycarbonate for longer duration of time in the UV light, then what will happen? They will turn to yellow. That means it give you a very great information, or it will be give you a very important information that your PC is going to be degraded. Okay, even though they have a very high melting point up to 267 degrees Celsius, excellent heat resistance, extreme plastic deformation, still, if you expose them, means if you keep them in the sunlight, because in the sunlight also few rays of UV came. Okay, so if you expose them for the very longer duration of time, this PC is about to be turned into the yellow in color. So once they come into this yellow color, uh, if you observe one thing, okay, I'm not telling you that this is exactly for all the polycondensation polymer, okay, but as I know, you heard about might be polyurethane also. Okay. So the polyurethane also one type of thermoplastic or thermoset polyurethane that come under both, huh? Whatever you want to synthesis, thermoplastic or thermoset. So this polyurethane also they manufacture from this polycondensation reaction. Okay, addition polycondensation reaction. And if that also exposed for longer duration time in the UV, you see that they turn into the yellow. So maximum polymer, those who synthesis, what I observe, okay, I'm not saying like every time it's occurred, but as for my experience and as for my observation, I found that the polymer that is manufactured from your polycondensation process, they are very less UV resistant. Okay, might be because of the ester linkage they have, because maximum polycondensation reaction, they form the ester linkage or the ether linkage, okay, or urea linkage. So might be due to that chemical reason also, they are less susceptibility to your UV light. Okay. So here this copolymerization or
You mean to say
incorporate,
less UV due to polycondensation, that condensation due to that only, right?
yeah, they will UV light will affect that polymer. Okay, like if you see when I will teach you the polyamide wala person also, there also we will see this. Okay, and this polyurethane, I think I don't know you have that or not, but in terms of few cellulose also. So whichever polymer they will synthesize from your polycondensation polymer, they are less resistance to this UV light.
Okay. Is there any other polymer we are making through that for condensation apart from PC?
Yeah, there are many polymer.
So all having less UV, right?
I can't say you that I'm
Okay.
saying now. He, as for my observation, because I deal with the polyurethane, I deal with the polycarbonates, or I deal with the cellulose, so I came to know that they will turn yellow. Suppose if you heat them for a longer duration of time, by giving the temperature also, okay, the temperature might be 70 to 80 also. Then if you place your material in that particular temperature for suppose 48 hour, you see that they will yellow in color, and you can easily break that polymer into two pieces.
Okay.
Okay,
Yeah.
that means they turn into the degradation stage. Okay,
Okay.
few of the bonds are break.
Okay. Do
Yeah.
you have any physical lab visit, like we can see, observe that all these things, because in the course,
Yeah. That I can't help you regarding because I didn't
mm,
have that much
at least one day
authority.
visit we can arrange, kind of maybe nearby, I think.
Uh, Sorry, I can't give you any kind of confirmation, or I can't answerable to that comment because that is not. Uh, I'm
Okay,
just
got
yeah,
it.
yeah. So here the copolymerization or the incorporation of additives are used to modify the base resin for greater creep resistance, UV light performance, flame retardance, and thermal stability. Just when I started my lecture, I told you every polymer has certain advantages but certain disadvantages also. To overcome that disadvantages, okay, because they have a very excellent property, and that property is going to help us for our own need of application. But we know that polymer have certain disadvantages. As like PC, they are excellent heat resistance, excellent plastic reason they have, then excellent they have abrasion that is more, and excellent transparency. that is 590 times more than your glass silicate. But what is the disadvantage is that PC, they cannot be resistance to this UV light. So I need this property of PC without harming the original property of the PC, but I want the resistance to the UV light also. To do that, we do the copolymerization, or we do the copolymerization, or we incorporate few of the additives. Is that clear? I I repeat it that every polymer have certain advantages and disadvantages. But to applicable that polymer to our own application, we change them according to our own needs. So how can we do that? Might be we do some copolymerization, means this PC will be copolymerized with some other polymer, those who are quite UV resistant, so we can solve the issue. Okay. Or either what I can do, I can add a few of the additives like UV stabilizer. UV stabilizer is a additives that we use. Like for that we have TiO2, titanium oxide. Okay, so many are UV stabilizer in the market that is available. Okay, so we add that into that polymer, so we can have a UV resistance to that material, and simultaneously, if we do that, we can achieve a very greater creep resistance as well as UV light performance, and we can increase the flame retardance. For the flame retardance, we can use mini flame retardance filler, and for the thermal stability. For example, I'll give you one example. Fire retardant grades of polycarbonates in the market. There is a very specific, I told you in that like polystyrene also. Okay, we study about HPS, EPS, different kind of polystyrene as per their need. Okay, so that in that way, this fire retardant grades of polycarbonates are made by the copolymerization bisphenol A with your tetrabromobisphenol A comonomer. Means we will add, okay, this bisphenol A, here we will add this polymer that is known as your tetrabromobisphenol A. Okay, this bisphenol A and tetrabromobisphenol A will give you the polycarbonate. That polycarbonate are highly flame retardant grade of polycarbonate. So suppose if you want to give a application of this polycarbonate, you want to use in, suppose in a household window cover, and there you can say like this window cover have also another advantages is that they are fire retardant. Okay, so in this way we solve the issue of the polymer while adding this glass fiber reinforcement greatly extend the level and raise the creep resistance of polycarbonate. See, creep resistance is also a very great, what can say, it is a also this poly PC have very less resistance to your creep. Okay, so for that, to increase the creep resistance of the PC, what they do, they add the glass fiber reinforcement. So when they add this glass fiber reinforcement in the polycarbonate, so they saw that there is a greatly extend, means the creep resistance is suddenly increased to a certain level. So in this manner, we can overcome the limitation of the polymer. But
We are
this,
eating glass in PP also, right? Due to that reason only.
yes,
Okay. Because
yeah,
I see many application PPGF we are using for structural part kind of.
yes, yes,
Okay.
yeah. But when we do this copolymerization or we added some filler, the price of that particular polymer is increased. Okay. So by doing this kind of copolymerization or the incorporation of additives, it increase the price. It is much more expensive than your glass and other plastic. Means when we do this copolymerization or the preparation of master batch of the PC, they are quite expensive, and that expensive, if we compare with the glass, then it is quite high as compared to also other plastic. Bisphenol A, you know that bisphenol A may have unpredicted effect on human. Repeated use of one object may be potential hazardous to health. But bisphenol A, uh, have you heard about that? The plastic bottle that we get in the market previously, the transparent one plastic bottle, okay, that we use for the storage of water, okay. Uh, Quite transparent in nature, they are using this bisphenol A. So, as for the government, this A is restricted. Okay, it is restricted for the preparation of polycarbonate while you are manufacturing the bottles or the drinking water bottles, as they have a very potential effect on the human health. These polycarbonate are highly sensitive to the abrasive cleaner. What do you mean by the abrasive cleaner? Suppose if you have a PC window that you placed at your home, so there you try to avoid like alkaline cleaning and some of the organic cleaning solvent. Don't use that because this polycarbonate are highly sensitive to your alkaline and your organic solvent. If you suppose, like you are using that what can we say, that cleaner, okay, yellow like some cleaner that is coming in the market for cleaning the windows and every uh, material that is when the dust is seated on that particular.
Me,
Okay.
Colin, you are talking about Colin, ma'am.
Yeah, yeah, Colin. So you have to take care of one thing. Okay. So whenever you have PC window or the PC material window in your home or any office or wherever, don't use harsh chemical to clean that particular window. That can be give you the side effect or that can be deteriorate your PC window quality. Okay. So that is the limitation of PC also. They are quite sensitive to this abrasive cleaner. Means if that cleaner is made up of strong alkaline or strong solvent like chlorine solvent, okay, chloroform or some other chlorine related solvent, so don't use that. That can affect the property of your PC. Okay. Simultaneously, this polycarbonate is susceptibility to degradation when exposed to the processing equipment for an extended period. What do you mean by this? That if suppose if you doing the if you are preparing a master batch of PC, means definitely you are going to use the extruded processing techniques for the preparation of master batch of PC. Okay, so there you have to take care of temperature. Why? Because we know PC have a high thermal stability. Okay, they are sustained to the temperature of 265 degrees Celsius. But if you keep that material, okay, if you keep that PC material in that particular extruder for a very long period of time, then there is a chances your PC might be degraded. Is that clear? Or if you are processing them by the injection molding also, so the what can I say? That time should be okay. Uh, the time of the contact of that material into the injection molding into that in between that you have extruder that you have low, then there is a chances they will be degrade soon. Okay, just give me 1 minute. हाँ ठीक है, मैं ना लेक्चर ले रही हूँ, तो कॉल करती हूँ। हम्म, हेलो, या am I audible, right?
Yes, yes, ma'am. Ma'am,
Okay,
you are telling that
yeah.
if it's retained in the barrel for a extended period, it will get degraded. That is common for all, no? Yeah, why this is?
See, that is not common for every material. Yeah, but you have to check the time. Okay. That is the reason why, because if that material is very thermal stable also, why? Because I'll tell you the reason. See, when this kind of structure are present, this structure have some limitation, means they have this double bond.
Yeah, yes,
O-
ma'am.
So when you receive maximum temperature to that, this bond they get lot of energy. Okay, and what will happen? This bond will break into two, and they will form two free radical. Okay, you might be study about this radical process. Okay, in the addition polymerization. Okay, when
Yes.
you have two radicals, this radical will start to break this bond, and again they try to form this. So this sort kind of process will happen if you keep that polymer longer time in your um processing technique. For that also you have a substituent. Okay. For that you need to add some thermal stabilizer additive to it.
Okay.
Or you can add some antioxidant. Uh, I'll give you one very good concept to this. See, here what you have oxygen. Okay. This bond is not that much strong because you have pi bond and sigma bond. Okay. So what will happen if you keep them for the longer contact na, this will be break and they will form oxygen. So that is you can have a oxidative degradation also. So that is the reason if you see they provide you the antioxidant additives also that. So, if you have some problem, some fault in your instrument, then that all the additives is about to protect your material. Okay. Although this polycarbonate rate high for impact strength when compared to ABS, PVC or acrylic, it is subject to the stress cracking. Okay, the impact strain, the impact strain of this PC is quite high as compared to the ABS, acrylobutyl styrene, acrylonitrile butyl styrene that we will study in after this slide only. PC have a better impact strength, but it have a limitation in the stress cracking. Okay, and this stress cracking might be occur due to many reasons. The reason might be some of the environmental factor or might be due to some sudden, as they have very good impact strength. See, the impact strength means what? When you apply sudden force to that material, then it will be break into the pieces. Okay, that is the strength of the material. Okay, how much it can sustain the sudden applied force on that particular material. But still, it has a high impact factor, but still it have a stress cracking. Okay, that is these are your few limitation of your polycarbonates. But as we have a limitation, but it have a very huge application. If you see this, can you see this panel? Okay, this is some electrical panels and the cover they have provided, they are quite transparent. This is made of the panel with your polycarbonate cover. How much it have a transparency? And this is the panel without polycarbonate, and this is the panel is quite thin. Okay, so this electronics component, okay, this electronics component means polycarbonate is mainly used for electronics application that is capitalized on its collective safety. Okay, for the safety purpose also, and they are good electrical insulation and having high heat resistance, flame retardant property. It is used in various products with the electrical and telecommunication hardware. It is served as a dielectric in high stability capacitor. Okay. So if you see that PC in your construction field, if you see this PC in the construction field, uh, have you ever seen this kind of poly house? This is known as your poly house or the that suppose in the swimming pool also to cover or to not to fall any kind of insect, they provide one kind of seal to that. Okay, so that is your made of a polycarbonate. And the poly houses also right now they are manufacturing with the help of your polycarbonate. So the second largest consumer,
Ma'am, your voice is we cannot hear your voice.
of polycarbonate, the
Your
second
voice is
largest,
breaking. Ma'am, your voice is frequently breaking. We could not hear.
uh, am I audible right now?
Yeah, in between your voice is coming and after some time it is going off.
Okay,
Now
okay,
it's
just give
okay.
me one.
Now it's okay.
Okay, okay. Uh, yeah, I'm audible right now, right? Is my voice is flickering?
Yeah, no, no.
No, clear,
So,
clear, very clear.
okay. So this PC, it is quite surprising to know that this PC have a like second largest consumer of PC is the construction industry for dome light. Okay, they use for the dome light or flat or curved glazing or the sound wall. Okay, sorry.
These are the few application that in the world largest consumer of PC they are using in the construction only. If you see that that different kind of PC seats are available in market means uh, this is a very special kind of PC seats where the two side UV follow seats. Okay, means two side they have a UV protection, and this is your four wall polycarbonate sheet. So this kind of different kind of innovation they do with the PC for this market demand. And if you see, this is your embossed polycarbonate sheet, means they will make you for some composite to it, and this is very common. Okay, everyone have seen this honeycomb polycarbonate sheets, and this is also connector. Okay, that they use in the household applications. As why these have a very huge demand, as they are quite transparent in nature. So you know, in the home right now in the construction industry, lot of people they invest lot of money in their luxuries. Okay, and the luxuries with their safety concern. Okay, that is quite natural today. So this PC, as we know, they are quite transparent in nature and the light can easily transmit it through that. So in the household also they are making the roof, okay, of a few roof of this PC so that sunlight can directly approach. Okay, it can directly fall upon the house, and as well as it will protect you from your protect you from rainy season or anything else. It is available in Amazon, variety range of thickness, whatever the thickness you want for your application point of view, you can got that. You can have a wide range of thickness. It was used in LED lighting, maximum lightning, if you see this PC, as I told you, there are transparency, so the refractive index play a very important role, and for that they have a very proper optical properties. It is used for the security application also. It can protect big facility from your bad weather. As I told you, you can shield your half house with the PC so the sun can come to your home, as well as you protect simultaneously from the rain or the bad weather also. So that is due to this all the applications, this PC have a very largest demand, second largest demand in the construction industry. As well as this PC, if you see this, all those CD players, okay, right now this DVD players are not, or the compact disc we are unable to see, but all those CD players or the discs, they are also manufactured from the PC, okay, and they are the injection molding polycarbonate, okay. And in automotive, aircraft, or the security components, they have a huge demand. If you see, these, you have seen in many of the times, this shield in the fighter jet plane or some aeroplanes, the wings or the narrow portion, they are made of your PC. In the automotive industry, these are your injection molded polycarbonate, can produce very smooth surface that make it suitable for direct metallized parts such as decorative bezels and optical reflectors.
Ma'am, can you move to previous slide, please? Previous to that, yeah. So, CD, okay. Yeah. Okay, you can continue.
So here, as I told you, as PC and PMA have a very quite similar characteristic. Okay. So on that basis, if you see the tensile strain of the PC is how much? 28 to 75. And this acrylic and PMMA has somehow the similar. Okay, there is no huge difference. Like the difference is not around 30 to 40 percentage. It is all about 10 percentage. Then the heat deflection temperature. So what will be the heat deflection temperature is 127 to, that is also somehow difference because polycarbonate due to the presence of the benzene group on it. Water absorption, if you see, this PMA may have little bit water absorption as compared to this polycarbonate. Hardness, this Rockwell M is the what can I say? That is the instrument where we calculate the hardness of that particular material. So the hardness, we have a PMMA may have more hardness. But when we come across UV resistance, this I'm talking about your UV resistance, polycarbonate, recent, just right now, like 5 to 10 minutes before only we came across that this PC have a very poor resistance towards the UV. Okay, whether if we'll compare that with the PMMA, they are very good or they have a inherent UV resistance. Okay, where only their chances is there कि 3% can be degraded by UV, but as compared to this polycarbonate, PMA may have a very good UV resistance group. Okay, as compared to the elongation is of
In the previous slide, it is mentioned that acrylic also. Why?
because polymethamethaacrylate come under your acrylic polymer.
Okay, okay, ma'am. Thank you.
Yeah. So the transparency, can you observe that the transparency value, they are almost similar. Okay. But if you see the chemical resistance, this PC have a strong chemical resistance to many common chemical, including acid, salt, grease, oil, or alcohol, but degrade in contact with methyl alcohol, acetone, and many hydrocarbons. Alkaline solution also, and can be cleaned with some common detergent and include ammonia. But if you see this PMMA, they are very poor resistance to salt or degrades in contact with acid, alkaline, ethanol, or other undiluted alcohol, but can be cleaned with your soapy water or acrylic cleaner only. So this differentiate I gave you because in the market you have a PMMA and PC. So both can be used. Okay, that depend upon your pockets, how much money you want to spend. But both have very similar kind of features. Some have some disadvantages like some stability or the chemical resistance is few in case of PMMA, but they can be sustained to some other chemicals like PC have some disadvantages like UV, but PMMA have a good UV stability. Okay, so the thing is that both you can use, but with their proper taken care. So we will right now we will study that I have already taught you in the vinyl polymer as your styrene. Okay, that is known as your polystyrene. But I like to introduce few of the copolymer because in your syllabus you have a styrene also. So I'm not going to repeat that styrene manufacturing again over here, but I will give you the few copolymers that is manufactured for the wider application of the styrene or the to fulfillment of the particular application that you want from the styrene or you want from the any of the copolymer. Okay. So firstly, we will study about your styrene butadiene rubber. Okay, that is known as your SBR. So styrene butadiene rubber is the largest volume synthetic elastomer that is commercially available. You know, SBR, can you anyone tell me SBR have a very different name in the market?
ABS? No, SBR.
That is known as Buna S. Buna S is a very commercial name to the styrene butadiene rubber. And it is the rubber that is largest volume synthetic elastomer currently the commercial available. It is made of, see, this is your 1,3-butadiene and this is your styrene. This is your copolymerization and it is happened by your free radical emulsion polymerization. Here, this SBR can be formed by two methods. You can either get from your emulsion polymerization or by your solution polymerization. In both the cases, you can find your SBR. But if you got your SBR from emulsion, they have a different application. If you are manufacture your SBR from solution, they have different application. So the both the application are different because they have a different property as well as. So it is generally a random copolymer. Okay. Random copolymer means the arrangement is quite random. Butadiene, styrene, then styrene, butadiene, the arrangement is quite different. So it is a random copolymer with a styrene contained in the range of 10 to 25%. Okay. And we do the copolymerization. I think I repeat 4 to 5 times also in today's lectures that we do the copolymerization or we add the additives just because to overcome the limitation of that particular polymer and to get the benefit of the required application. Okay. So for that reason, but in SBR, the styrene content is about 10 to 25%. Okay. It can be produced by free radical emulsion polymerization of styrene and butadiene either at 50 to 60 degrees Celsius. Hot emulsion or if we prepare in the temperature between 50 to 60, so we called them hot emulsion SB. If we synthesis this particular, if we do the emulsion at 5 degrees Celsius, we call them the cold emulsion SBR. SBR also produced by the anionic solution polymerization. As I told you, it is produced by the emulsion polymerization as well as your solution polymerization of styrene and butadiene with the alkyl lithium initiator like butyl lithium in the hydrocarbon solvent, usually hexane or cyclohexane. Okay. So SBR is what? It is a thermoplastic elastomer which behave just like a elastomeric rubber at room temperature, but when it is heated can be processed like the plastic. This SBR will, in the room temperature, they will behave like the elastomer or the rubber. Okay. But when you provide them the temperature, they will behave like the plastic. As styrene is a plastic and 1,3-butadiene, that is the monomer that we take for the preparation of your butadiene rubber. You know, butadiene is a rubber.
EPDM is also rubber, right?
Yeah, EPDM also.
Where is the SBR application?
Yes,
Where in automotive, where we are using SBR?
I'll come into that in the
Okay, okay.
production of tire.
Okay, that is at SBR only.
Yes, SBR.
Okay.
Ma'am,
Okay.
it acts as a rubber, but by heating it will act as a plastic, you told.
Yes.
Is there any application where the same thing heated and it is used here, and in cold condition we are using here.
I'll tell you. Okay, just wait. Just wait. The presence of styrene, okay, the presence of styrene contribute to the good weathering and bonding characteristic of SBR and reduce its price. See, what I told you, see the styrene have some advantages as butadiene also have some advantages. So whatever the overall property we will get by doing this copolymerization or by getting this SBR, here we can this individual property or this individual polymer, they can have their own property as like the presence of styrene contribute to the good weathering. We know that we have studied in previous lecture that polystyrene is a very good stability in weather stability or good wearing and bonding characteristic of SBR and reduce its price. Butadiene unit in SBR are composed approximately, okay, uh, you know, like trans and cis, that is the two form because we are using the butadiene. So here in this CH and this CH, you will see like this CH or this CH2, you can see the trans and cis, that will be the two conformation. Okay, that is, sorry, not conformation, that is a configuration. Two configuration will be formed. So the butadiene unit in SBR is composed 60 to 70% trans, 20% cis, and 50 to 20% is 1,2 configuration of polymer at 50 degrees Celsius. This is the composition of SBR. Okay. So where we use this SBR, okay, the major use of SBR is in the production of tire, particularly the passenger car and the light truck tires, or in other automotive application where SBR is blended with other elastomer. So this tire manufacturing and this passenger car and the light trucks tire, this all have a use as a tire in your automobile application. Okay. And you can use this SBIR of in other application if you blend them with the some other elastomer. So what are the application?
But the
First,
tire, if we heat it will melt.
yeah, they are melt now.
Okay, because it's
You
burning
that is
kind of, right?
no. Firstly, they will melt, but when you heated them at high temperature, they turn into the carbon.
Okay.
Yeah,
Uh,
and that is the reason. Suppose why you have lot of puncture during your hot season when there is a temperature is above 35 40 degrees Celsius. Okay, you might be heard that lot of puncture and everything occur. Okay, that is the reason because you
right.
cross the limit.
And apart from the tire, any other automotive application?
Yeah, here you see now we are about to,
Okay, please
this is
continue.
the rings, okay, gasket, okay, or for the shoe sole we use this. As I told you,
I'm talking about automotive application. Um,
yeah, I will tell you.
okay.
Yeah. So, emulsion SBR means suppose if you got the SBR from the emulsion, then use that maximum they have application in the shoes heel or soles, okay, this kind of things, or gasket. This is the gasket that have an automobile industry application also. Latex. SBR is extremely used in coated paper or being one of the cheapest resin to bind the pigments coating. Okay. to stick also for the sticking. They also use for the binding. If you know the binding, book binding and everything, there also this emulsion SBR they used. So they can properly bind. Then uh, if you have your polystyrene that polystyrene not SBR that you get from your solution polymerization, then you got a very hard rubber. Okay, that is used for things like the soles of shoes, tire treads. Tire treads means if you see this lining above the tire, okay, if you see this, that is known as your tire treads or other places where durability is important. Means if you want that particular material should have a longer durability, okay, means you want to use them for a very quite longer period of time, then you can use the solution SBR other because they are quite hard rubber. But if you talk about emulsion SBR, they are quite soft in nature, and that is the reason they can use like for the manufacturing of very soft uh, product.
Okay.
And this SBR also that artificial leather belt they are manufacturing, that also you can do that.
And
And this
what is that image above that seal, right?
this one,
No, above tire,
this one, na?
above tire. This one, yeah.
Yeah, actually these are the that is they are using in automobile. I know that, but what purpose they are using, I don't know that.
This is that seal, right? That
Yeah,
door seal kind of, right?
yes,
Yeah, sides of door, this will come.
This is AB flange seal kind of, I think.
yeah. For the stopper, right now it is
Door
available.
stopper. Yeah.
Yeah, door stopper. They are quite soft and they are quite flexible.
Okay.
Yeah. Next is your styrene acrylonitrile copolymer that is known as SAN. Okay.
What
Uh,
about that
Ma'am,
S
that rubber which is heated, which one are heated and which one are without heated?
you are saying SBR.
So
See,
you told, so if without heating, if we do, it will work as a rubber only. When we heat it, it turns into a plastic. In that,
yes.
just asking. It's like sole you are talking about, huh? So sole, it is heated and produced.
Yes, initially they are quite soft. Okay, that's why you cut it into because these sole are manufactured by using the compression molding. You all
Oh,
know that.
mm,
Okay, we
right, right.
manufacture this sole by using the compression molding. So to feed into the raw material, what you feed in the compression molding, you should cut it into very small chunks, or you will have to use pellet or powder. Okay, these are the three forms of material that we feed into the compression molding. Am I right?
Which three? One pallet, one powder, and another.
One chunks you need to cut that particular, suppose you have a seat, okay, so you need to cut them into very small chunks or
Got it, got
small
it,
pieces,
got it.
okay, that you place in this compression molding, and then you start your process, and after the release of that doing the breathing, then when you remove the upper half platen, you got your product as for your mold you have designed. Okay, so in the sole, okay, you cut it into the chunks, means if they are soft, that is the reason you can cut it them into the chunks, but when you provide them the heat, they become quite strong and hard. Okay.
Okay, ma'am.
Yeah.
And regarding rubber only, that
Hmm.
EPDM also, because I seen that SBR we are using for floor mat,
Mm-hmm.
that export purpose. but
Hmm.
also Matt, we are using EPDM. So what is the pros and cons if I compare SBR and EPDM? Both are rubber, right?
Yeah, but the chemical structure is quite different.
Are we going to cover in EPDM also in upcoming classes?
I don't know about EPDM. I need to see your syllabus, but elastomer, if they are, then they will cover that. These I taught you this SBR because this is a copolymer of styrene.
Yeah,
And
got it. But
in
actually, because generally in automotive we are using that EPDM also floor mat. So sometimes we
okay,
have to do that target balancing. So if we have a
if
good
I got,
comparison,
listen to me, if I got time, then I will teach you. Okay.
yeah.
Otherwise, I'll see if someone will able to take. Okay.
Okay, I'm noting the question. Okay,
Yeah.
thank you.
Yeah. So styrene acrylonitrile copolymer, that is known as your SAN. This is the short form of that. So what is this styrene-acrylonitrile? This is the styrene person and this is your acrylonitrile person. And they are copolymerized to form your styrene acrylonitrile copolymer, and it is a copolymer of plastic containing styrene and acrylonitrile. This sand copolymer where you have a 20 to 30% is your acrylonitrile content as compared to your styrene, and are relatively expensive and specialized engineering plastic based on the styrene. These sand are quite costly and it is only produced on a very special demand. Okay. Uh, they have a very better resistance to hydrocarbons, oils, or greases than the PC. As compared to the polystyrene, these sand have a very better resistance to for the chemicals. They have a very higher softening point, a much better resistance to the stress cracking, as well as grazing and enhance impact strength and yet retain the transparency of your homopolymer. See, it give you the combination of both styrene and acrylonitrile. You know styrene have the transparency. So this sand have also the transparency, including that they have a very they are the better stress cracking resistance and impact strength also. But this sand is not readily available. It is a huge it is quite expensive and only manufactured why only when there is a need. Rigidity, and why that I will also tell you. Rigidity and transparency make sand competitive with the polystyrene. As compared to polystyrene, these sand are quite transparent and rigid. Cellulose acetate polymethamethacrylate for a number of application. Means as compared to cellulose and polymethamethacrylate, means PMMA, these sand have a very high rigidity and transparency. Sand copolymer have found application for dials, knobs, or cover for the domestic appliance, electrical and car equipment for picnic wear or houseware, or number of other industrial domestic. I'll show you the application also. If you saw this kind of very fancy kind of baby feeding bottles also, that is the like manufacture by using this styrene acrylonitrile nitrile copolymer, and this transparency and the colorful bottles, they are also manufactured. This is not bottles, but this is the lighter they are using. Okay, but this lighter, as I told you, this sand have a very high resistance to oil, grease, and flammable, not flammable, but they are quite resistant to all those chemicals. That is the reason the lighter that we purchase, that outer cover of that, they are made of sand. Kitchenware, you can see lot of jars and different color of bottles, basin or fitting for a refrigerator. All the cutleries, coffee filters, jar and beakers, they all are maximum. They are made of sand, but that will be little bit costly to you also. In electrical appliance, as I told you, knobs, dials, or the cover for the electrical equipment. It is used in the auto parts, automobile industry. They are used for the auto parts also due to its higher impact strength. It is used in the computer product and pharmaceutical and cosmetic packaging. If you see this, I give you a pictorial diagram to that. Here the drop, eye drop or some kind of drop that you uh, took for the medicine, the bottle that you saw, they are made of your sand. A bathroom fitting and toothbrush also they are using. For battery housing, writing and drawing equipments, okay, that you got, that also manufactured from the sand. Cylindrical impeller of the air conditioner, as they are also manufacturing from your sand.
SAN is used for auto parts. Which auto parts?
Uh, which auto parts? I don't know, but it has a auto parts means where we are using the pneumatic or hydraulic. There, we use this styrene acrylonitrile copolymer. Particular where it use, I don't know, but I know wherever you use like pneumatic and hydraulic, they are this kind of use. We use this because they are quite resistant to grease and oil.
But pneumatic air also, right?
Yeah, pneumatic means air pressure.
Okay, that means air also. Grease, oil, air also. Okay.
Yeah. Next, copolymer we have, that is known as your acrylonitrile butadiene styrene. So what happened in your acrylonitrile butadiene styrene? It is a combination or the copolymerization of three polymer. What is that? One is your acrylonitrile, another one is your butadiene, and the styrene. What we saw here, styrene and acrylonitrile. Uh, and here what we study, styrene and butadiene. But we will take the combination of three polymer. Okay, what is that? Butadiene we have, acrylonitrile we have, and the styrene. That is known as your ABS. I think everybody heard this. They are quite market in demand. This like acrylonitrile ABS resin, okay, are produced primarily by grafting styrene and acrylonitrile on the polybutadiene latex in a batch. You can prepare them in the batch or the continuous polymerizing process. They may also made of blending emulsion. They form in the emulsion polymerization latex of styrene acrylonitrile and nitrile rubber. So they do the blending in the emulsion polymerization of styroacrylonitrile, that is your SN, and NRB, that is your nitrile rubber. So in that way, they produce the ABS. So acrylonitrile provide heat. So as I told you, this particular polymer, they have a particular application. So we will study what is the role of acrylonitrile here, what is the role of butadiene as well as styrene. So this presence of this acrylonitrile, acrylonitrile provides heat and chemical resistance and high strength. Okay. The role of acrylonitrile in this ABS is that they will provide you heat, chemical resistance, and high strength. What is the role of butadiene? Butadiene acts as a reinforcing agent. Okay, it acts as a reinforcing agent, providing impact strength and toughness even at low temperature. We know butadiene is a monomer for the elastomer, and they are very flexible at the room temperature also. So due to that, they will provide you a very high impact strength and toughness at very low temperature. So this ABS can be act from a low temperature to a very high temperature. Whereas your styrene contribute rigidity, easy processability, and gloss. Okay, so as this combination, as we know, acrylic will give you very high resistance to heat and chemical as well as your strain, and this butadiene will help you to act in a very low temperature, also giving you a very high impact strength, and this styrene contribute the rigidity and the easy processability and the luster property. So by combining these three important monomer to give you ABS, there is one known as general purpose ABS. Okay, this is a type grade of ABS that is known as general purpose ABS. We have like general purpose styrene. Okay, that is GPS. Here we have general purpose ABS where include both medium impact strength and high impact strength grade, as well as low temperature, high impact strength variety. Means it is a combination of both the type. Okay, like medium impact strength and high impact strength grade, as well as low temperature, high impact strength variety also. In addition, there are you can get like flame retardant ABS, structural foam, heat resistance, low gloss, and transparent. These are the different kind of grade of ABS that is available in the market. You will use as for your convenient, as per your application point of view. You have to decide it what grades of ABS you need. If you want your final product should provide you very medium impact strength, that also available. If you want high impact strength grade, that also available. As well as if you want low temperature, high impact strength, that also available. ABS resin have relatively good electrical insulation property. They are quite resistant. They have a very high resistance to weak acid, weak and strong bases. Okay. However, they are poor resistance to ester, means they are poor resistance to ester, ketones, aldehyde, and some chlorinated hydrocarbons. ABS resins can easily decorated by painting, vacuum metallizing, and electroplating. Okay, here also that can be done. Means this ABS resin, where you have put it, there you can do the painting, vacuum metallization, and electroplating.
Basically, paintability of ABS is more. That's why we are using an exterior panel kind of.
Yes.
Yeah.
Processed by all techniques means you can process or you can do the compounding of this ABS like in the cold form, okay, or you can use any of the techniques to process this thermoplastic ABS, okay. And ABS as I told you, ABS have a very good impact, but it has a very important drawbacks or the limitation, that is ABS is hygroscopic. What do you mean by the hygroscopic? Means they easily capture the moisture. Okay. Therefore, whenever you are using ABS for the processing, you have to be pre-dry or pre-dry the ABS properly before you are doing the processing. And ABS is finding, or you can have them in the injection molded ABS, that is you use for houseware, small toys, telephones, or pipe fitting, which are application required for prolonged use under severe condition. Means the condition might be sometime temperature is low, or sometime temperature is high. In every condition, this injection molded ABS can be used. Then we have extruded ABS sheet, that is also available in market, is used in one piece camper top or cans. ABS sheet means where you go for some tracking or somewhere, there you can use that for a camper tops or cans. Then we have a profile extruded ABS resin that you use for the pipe or sewage pipes or well caching or conduct. Means these are for the pipelines. Also, you can use this ABS, but they are extruded. You know, pipes we manufacture from the extruded only. So some specialty product from ABS include electroplating grades, that is used for the automobile grills and exterior decorative trims. High temperature resistant grades, that is used for the automotive industry instrument panel and power tool housing. And structural foam grade, which are used in the molded part where higher strength to weight ratio is required. So these are basically different kind of grade of ABS. And in this, as I told you, ABS processed by all techniques. So here I gave you key we can use by every kind of processing, but it have a different application.
What we mean by profile extruded ABS?
Profile extruded ABS means, twin screw extruder. Okay. There we manufacture pipes. Okay. So while you manufacture the pipes, if you saw the process, you just take the pipes and try to connect in a hollow pipe. So that is known as your profile extruded ABS.
Okay, basically it's a kind of a
Pipes making techniques.
pipe,
Yeah.
basically pipe making technique, yeah.
Hmm.
And extruded ABS sheet means kind of a sheet which you are using in vacuum forming also, or like,
Yes, and that is used in that making the tents house or the
yeah,
that you are.
you extruded cylinder, yeah, kind of, yeah.
Yes.
Roller.
Yeah. So like we will have your next lecture on coming Monday, that will also taken by me, and we will have polyamide, I think so.
Ma'am, there is one doubt. All the chemicals, whatever we have seen now, is there
Hmm.
any way to understand or remember all these things? Is there any technique we can follow?
Yeah, because yeah, you're right. Because that memorizing is very difficult. All these things.
Because
Yeah,
it
I
also
see. You didn't need to be memorize all those chemicals. You need to be like just for your industrial application, if you are asking, then just have a look into the Google. Otherwise, you can't remember. Even I can't also remember.
Ma'am, but question having all this that chemical, all this structure, right? How will remember all this paper? Why? Because we have to give the exam also, right?
Yeah. So don't write the chemical part. Just write few of the chemicals. Don't see. You do one common thing. acid and alkaline, these are very common, okay, in every property. So try to memorize that in which they are poorly resistance, where they are strongly resistance. That give you lot of chemical resistance proof. Is that clear?
Yeah.
So like
Okay.
which polymer have like highly solid resistance, sorry, acid resistance, poorly base resistant, that you have to rememorize, or hydrocarbons. That's all. Or aromatic. These are the four things. Okay. Alkyl, acid, hydrocarbons,
Uh,
aromatic.
Ma'am, it is like what I'm asking is in 10th standard and other thing, a small, some 20-page pocket books used to come for our remembering all the formulas like that. Is there anything available in Google?
No, no, no. No, you can't have that one.
Uh, basically,
Yeah.
basically we are expecting some notes which might be shared by DP. They can give some handy books which will just help us or kind of.
And whatever the after the lecture they are sharing something, but when we click it, it says nothing is uploaded in this. That is a message we are getting. I'm not able to open any of the videos so far. Actually,
Okay, they
that
will
link
give
is there.
you.
When we click the link, immediately it is saying there is no upload in
Actually,
nothing.
what happened? Yeah, actually, what happened? Same issue I am also facing. When I send a mail, they told that video is valid for 72 hours only. But while admission, no one talk about this. And generally, we are working people that unable to
Okay,
attend.
please you
Yeah,
talk with the DP people only.
yeah. Yeah,
But
that's
they are
related
doing
DP
the
only.
recording. They are doing the recording. This whole are recorded
But
videos
I
only.
requested, they told that's what old videos. I didn't attended any video, so I'm missing that portion. That's what some basics I'm missing here. And I
Okay,
requested
don't
that.
worry that you will get the like slide also. You will get every slides. Okay, we will
Yeah.
make into the PDF and we will share with the DP people and they will share with you. That is
Basically,
no problem.
basically we should get that recorded video because other bits planning all this, we are getting a recorded video and it's lifelong kind of. But here it's only 72 hours. Later on, if for paper preparation, we can quickly rewind quickly and kind of prepare. Your notes,
Okay,
yeah.
yeah, it's better you talk with
Basically,
them.
yeah,
Yeah, please, huh?
yeah.
Okay. So thank you so much. See you in the next Monday lecture. Okay?
Okay. Monday, which topic you are going to cover? Sorry, Monday.
Polyamide.
Polyamide. Okay.
Yeah. Okay.
Okay, ma'am.
Yeah. Bye.
Thank
See you
you.
in the
Thank you.
Monday.
Thank you, ma'am. Yeah. Hello.